Hello, everyone, and welcome to our final presentation for our project for ME210 Electronics and Systems Engineering. My name is Rodrigo Diaz, and I am in Group 12 with Manuel Jimenez, and our presentation will be over our project we call uino, which is a vacuum. And I will go ahead and turn it over now to Manuel for the overview.
So the uino was meant to be a self-powered vacuum that would self-navigate around the room. And our idea for this was mostly because we are busy college students that didn't want to spend time doing a needless task when we can be doing other things like studying.
For this project, what we needed equipment-wise is, of course, the smart car robot, which is the one that comes in regularly, the ultrasonic sensor to sense the distances around itself, the Arduino board to control it all, as well as what makes this project a vacuino is the little handheld vacuum. Now, this vacuum is a small one that can be used on desktops, and that's what we found to work best on this robot. And we also needed a way to mount this onto the cart itself, which we used duct tape, but Velcro tape or any other kind of tape will work fine just for this part of it. Now for the schematic and circuit diagram that we used for this project is very similar to the schematic that we used for the obstacle avoidance, which we've been talking a lot throughout this presentation, but essentially it's an improvement upon that. And we did manage to get the vacuum to get powered on and off with when the Arduino does that too. So we were able to incorporate that into the circuit diagram, as you can see here.
Our code was built like a regular obstacle avoidance code. It would move forward until the ultrasonic sensor measurement was below 40, and if there was an obstacle, the servo measurement would activate, so it would look both left and right, and depending on which distance was greater, it would turn in that direction before starting the entire code over again. This code did give us some challenges. We were not able to directly power the vacuum with the robot, and at times we would get inaccurate measurements if there was not well-lit areas within the room, and we're not sure if the sensor might have had issues because we didn't have a chance to exchange it for a different one since we are out-of-state students. Because of this sensor issue, the robot would sometimes get stuck at corners. It would either crash before turning, or it would have the sensor turn left and right a few times before finally making a full turn and proceeding with the code. Our final issue was figuring out how much power output to put, because at times it would move too fast for the vacuum to work and pick up trash, but on the other hand it was too heavy for it to move, so we had to find the perfect power for it.